let us look at limit of a sequence. But before we look at the limit, let's understand a little bit or very briefly about magnitudes. Given a number x in real numbers, magnitude of x is equal to minus x if x is less than 0 and x if x is greater than or equal to 0. Because when x is less than 0, this becomes minus minus x. So x. Okay. So magnitude of x is equal to a means x is equal to plus or minus a, where a is greater than equal to 0. Magnitude of x is the distance of a real number x from the real number 0. Distance between two numbers x comma y in real numbers is magnitude of x minus y. Now, properties of magnitudes. Magnitude of x plus y is less than or equal to magnitude of x plus magnitude of y. Suddenly, how did this less than or equal to come? Because what happens is, here if both x and y are positive, then these two expressions will be equal. But if one or both of them are negative, this will become a smaller value. And once we take the absolute value, it will be a positive value. And here what is happening? Whether x is negative or positive, absolute value of x will give us x. This will give us y. So this will always be a proper addition. Okay. The second one is magnitude of x minus y is less than or equal to magnitude of x plus magnitude of y. Oh, how do we justify this? Straightforward. We can convert this x minus y into x plus a negative y. So we end up with this itself. And that is why this is also less than or equal to magnitude of x plus magnitude of y. Magnitude of x times y is equal to magnitude of x times magnitude of y. Magnitude of x divided by y is equal to magnitude of x divided by magnitude of y, where y is not equal to 0. This is very important to understand. Now let's get on to the limit of a sequence. Let a sub n be a sequence. The limit of this sequence a sub n is a value that the terms of the sequence approach as the index n goes to infinity. More formally, a sequence a sub n is said to have a limit L if for every epsilon greater than 0, there exists an index m in the set of natural numbers depending on epsilon, such that for all n greater than m, magnitude of a sub n minus L is less than epsilon. So what does this mean? Quite a mouthful. So let's see. Magnitude of a sub n minus L is less than epsilon implies that a sub n minus L is between minus epsilon and epsilon. Adding L throughout, we get L minus epsilon is less than a sub n, which is less than L plus epsilon, which implies a sub n is between L minus epsilon and L plus epsilon. This means that the distance between the term a sub n and L is less than epsilon. And here remember, we choose epsilon depending on how close we want to get. Because this inequality holds for every epsilon greater than 0 and for all sufficiently large indices n greater than m, the terms of the sequence must get arbitrarily close to L as n increases. We choose a particular epsilon and we start writing the terms. As we start writing the terms, what will happen is n will get incremented. So as n we keep increasing, we will reach a particular index m, beyond which we will have the terms closer and closer to L. Let's look at an example and understand this. Let's take the sequence a n is equal to 1 by n. Now we know as n becomes larger and larger, a of n goes to 0. Depending on our requirement, we can get as close to 0 as we want. But we know that 1 by n itself will never become 0, however large the n is. Magnitude of 1 by n minus 0 is less than epsilon. Here, remember, epsilon we choose depending on our requirement of how close we want to get to 0, which implies 1 by n minus 0 is between minus epsilon and epsilon, which implies 1 by n is between minus epsilon and epsilon. 0 we can ignore. Now, another thing is, since n is a natural number, means 1 by n is always positive. That means we don't have to bother with negative numbers. So we ignore the left-hand side inequality. And we can just restrict ourselves to the right-hand side inequality. 1 by n is less than epsilon. For example, if we want to get within 100th distance of the limit, that is 0, epsilon would be 1 by 100. Here, remember, the limit is 0. Epsilon we are choosing as 1 by 100. We want to get that close to 0. That implies 1 by n is less than 1 by 100. Manipulating that, we get 100 is less than n. Or we can say n is greater than 100. 100th term is on the boundary, because remember, we want to get within 100. So 100th term is on the boundary, hence 101st term onwards, the terms are within the epsilon distance of the limit L. Now let's look at it graphically. Let's say this is 0, which is our limit for this particular sequence, 1 by n. And let's graph the terms of the sequence. So this is the first term, 1 by 1. Second term, 1 by 2, 1 by 3, 1 by 4, and so on. And we can see it gets closer and closer to 0. And here it looks as if it becomes equal to 0. Let's see. Let's zoom in. Let's keep zooming in and see what happens. See, it is actually outside this circle. That means it is not equal to 0. It is very close to 0, but it is not equal to 0. So how does this epsilon concept come into picture? Basically, we choose an epsilon value. So let's say I have chosen, let me go back to the original setting here. Now let's choose 2 lines, or rather 2 points, plus or minus epsilon. I'm drawing a line because if I draw it as a point, it will not be visible. Now I zoom. The epsilon I have chosen is 0.015. So we want to get within that range of the limit. So limit is this, because we know an goes to 0. So limit is 0. And all the points here are within epsilon, are less than epsilon. Now let me just zoom in so that we can see it clearly. I can go to any value of epsilon. I have already reached 1000 terms to reach here. And we know it will never actually become equal to 0. So we say it tends to 0. And here we don't really require this side, negative side of 0, epsilon, because our terms never become negative. So we can remove this. But if we had some other sequence, let me just draw it, -1 to the power of n divided by n. So this is how it will look like. Now the rest of the discussion doesn't have anything to do with this particular sequence. But now we need to show the negative epsilon also. This is our limit L. This is minus epsilon. This is plus epsilon. And we can reduce the distance between the limit and the term such that it becomes less than epsilon. So all these terms are less than epsilon. Generally speaking, we write this concept of limit of a sequence as limit as n goes to infinity of a sub n is equal to L. Our example, we would write it as limit as n goes to infinity of 1 by n is equal to 0. Be very clear about this part. If limit as n goes to infinity of a sub n is equal to L, that means what? L is, remember, a finite quantity. So that means the sequence is going towards that value. So we say A of n is a convergent sequence, or simply as A of n is convergent. But there might be cases where it doesn't actually go to any or tend to any specific finite value. So if limit as n goes to infinity of A of n is not a finite number, we say A of n is divergent. So convergent, divergent. So that was limit of a sequence. Now, if you found this session helpful, please do like, share, and subscribe. Comment suggestions are always welcome. Thanks for watching. See you in the next session. That's it for now. Bye.